Good morning children, Sairam. Children, in the previous part of this chapter structure of atom, we all have discussed about the Bohr's model of atom. Before that, I have told you many other models were also given, but they all were discarded, like Thomson model, which was like a plum pudding model, that was discarded. After that, Rutherford model was also given. About Rutherford model, you all have learned in 9th standard. He conducted an Rutherford alpha scattering experiment, and on the basis of that, he discovered the nucleus. After that, Bohr's model was given. Bohr gave the concept of fixed atomic orbitals in which the electrons rotate around the nucleus. Now, today we will be discussing about what all developments led to the discovery of Bohr's model of atom. Now children, there are certain developments because of which the Bohr's model of atom came into existence. Now what are these developments? The first one is dual character of electromagnetic radiation. You all know what are electromagnetic radiations? Electromagnetic radiations are those which travel in the space and have electric and magnetic field associated with them. There is a dual character of these electromagnetic radiations. They are radiations, so they travel in the form of wave. But there were certain experiments which were observed, and these experiments showed that they do not have the only wave nature, they have particle nature also. Now, because of this dual nature of electromagnetic radiation, that is wave nature as well as the particle nature, there was the need of discovery of Bohr's model of atom. Second is the requirement for quantized electronic arrangement in atoms. Now, why is there a requirement for quantized arrangement in atoms? Quantized arrangement means, as I told you, that in Bohr model we have learned that only those orbitals are permitted in which the angular momentum is a integral multiple of h upon 4 pi. That means there is a quantized energy for angular momentum. That means only those orbitals will be permitted in which there will be some quantization of energy. Now, why this need arise? Because the spectra of many atoms was studied through the spectroscopy, and with the help of that it was discovered that the spectra is giving radiations, or you can say the spectra is giving colors at a particular frequency only. Not everywhere it was giving color, but at particular frequencies. That means they will be present at particular spaces only. Now children, will be studying in detail about the dual character of electromagnetic radiation today. Now see, the first character which is shown by the electromagnetic radiation is the wave nature. You all already know about the waves. Waves have this to and from motion around the direction of propagation of the wave. Now you all can see this in the diagram, that this is an electromagnetic wave traveling. This electromagnetic wave is traveling, and it has the magnetic field component as well as the electric field component. Now, the magnetic field component and the electric field component, they travel in the direction which is perpendicular to the direction of the propagation of wave. The wave is traveling in this direction. They both are also traveling in the same direction, but they are traveling perpendicularly, and they are having a angle of 90 degree with each other also. So, what are electromagnetic radiations? Electromagnetic radiations are those which travel in the space and have electric and magnetic field associated with them. Now, this electric and magnetic field also travel with electromagnetic radiation. They travel in the direction perpendicular to the direction of the propagation of wave. Now, for this wave, you can find out the relationship between the wavelength, frequency, intensity you all know, and you can relate it with the speed of light also. Now see, as it is a wave, now if we see here we have the spectrum of electromagnetic radiations. By visible spectrum also you all can see this is only a small part of the electromagnetic radiation. Now here the electromagnetic radiations, they all are arranged in the order of increasing frequency, or you can say decreasing wavelength. It is the same. Now if we see from this side, the first one is gamma rays, then is X-rays, UV rays, then the visible spectrum that has been broadened down, then infrared rays, microwaves, FM radio waves or AM, and long radio waves. Now you all can see these waves are arranged in the order of increasing frequency or decreasing wavelength. You all have to learn this sequence, that first of all which wave will come, that is gamma rays, then X-rays, then UV rays, then visible spectrum, then is IR rays, that is infrared, microwave, radio waves, and long radio waves. Next is the particle nature of electromagnetic radiation. Now children, there are many phenomena which are explained on the basis of wave nature, like diffraction, interference. You all have learned about this in physics in 9th and 10th standard. Diffraction and interference. Now these phenomena which are shown by the radiation, they can be explained on the basis of wave nature. But there were certain phenomena which were exhibited by the radiations, but they cannot be explained on the basis of wave nature. So it was proposed that by Planck, it was proposed that the electromagnetic radiation possess the particle nature as well. Now we'll study about the particle nature, or you can say Planck's quantum theory of radiation. Particle nature means the Planck's quantum theory of radiation. Now what Planck said, according to Planck's quantum theory of radiation, whenever a substance is heated, it emits radiation over a wide range of wavelength. These radiations go from lower frequency to higher frequency as the temperature increases. Like for example, you can take an example of an iron rod. When an iron rod is heated, it turns to dull red, then it turns progressively to more red as the temperature increases. That means when iron rod is heated in a furnace, you can say, then as the increase in temperature takes place, the intensity of the color also increases. Why it increases? Because the frequency is increasing. So we can say that Planck, according to Planck, the energy is emitted or absorbed discontinuously. That means when energy falls on a substance, it is it is absorbed discontinuously, not continuously. It is discontinuously in the forms of small packets of energy, and these packets of energy are termed as quanta, or you can say the energy associated with one quanta is one photon of energy, and it is equal to E is equals to h nu. Nu here is the frequency and h is the Planck constant. So again I am repeating, according to Planck's quantum theory of radiation, the energy emitted or absorbed is discontinuous, it is discrete in the forms of small packets, and the energy associated with each packet is equal to h nu, where h is the Planck's constant and nu is the frequency. So it is called photon of energy or quanta of energy. Now the value of Planck's constant is 6.626 into 10 raised to the power minus 34 joule second. So this is your value of Planck's constant H. Now you all must be remembering when we were doing the Bohr's model of atom, I told you about H and I told you I'll discuss about H later on, this small h. In Planck's Bohr's model of atom, you all were learning that the angular momentum is an integral multiple of h upon 4 pi. That h was actually the Planck's constant and its value is equals to 6.626 into 10 raised to power minus 34 joules second. Now, as I told you, the electromagnetic radiation is showing dual nature. One is the wave nature. On the basis of wave nature, we can explain the phenomena like interference and diffraction. And second is the this particle nature. Particle nature was given by Planck's quantum theory of radiation, and according to particle nature, we can explain the phenomena like your photoelectric effect and black body radiation. Now see what is photoelectric effect. See children, according to this photoelectric effect, suppose we have this metal surface. This is the metal surface. Now what photoelectric effect states? It states that this is the light falling on the metal surface. Now what happens? According to photoelectric effect, when light of suitable frequency strikes on the surface of the metal, then electrons are emitted from the surface of the metal. That means the phenomena of ejection of electrons from the surface of metal when light of suitable frequency strikes on it is called photoelectric effect. Now, how photoelectric effect was explained on the basis of Planck's constant theory of radiation? It is when light of suitable frequency. Suitable frequency means the frequency should be such that it can provide E is equal to h nu amount of energy to the electron. Then only the electron will come out of the metal surface. Now all metals do not show this photoelectric effect. There are only certain metals like cesium can easily show your photoelectric effect. Now you have to learn the definition for photoelectric effect. The phenomena of ejection of electrons from the surface of the metal when light of suitable frequency strikes on it is called photoelectric effect. And do draw this diagram also in which I have shown you that we have taken a metal surface, that means a sheet of metal. The light of suitable frequency is striking on this sheet of metal. Electron is ejected and the detector is used to find out the ejected electron. Clear? Now coming to the next phenomena that is explained on the basis of your particle nature, that is the first of all we'll study about this important observations of the photoelectric effect, then we'll proceed for the black body radiation. Now according to this photoelectric effect, according to Planck's behavior, the electrons are ejected from the surface of the metal as soon as the beam of light strikes on the metal. That means when the beam of light strikes on the metal, at the same time electrons are ejected. That is, there is no time lag between the striking of the light beam and ejection of electron from the metal surface. Now second important observation of the photoelectric effect is the total number of electrons ejected is proportional to the intensity or brightness of light. That means the number of electrons ejected depends upon the intensity, not on the frequency. Third important point is, for each metal there is a characteristic minimum frequency that is called nu naught, which is required for the ejection of electron, below which photoelectric effect cannot be observed. That means if the frequency is less than nu naught, that is the threshold frequency we call it. If it is less than threshold frequency, then ejection of electron cannot take place and the photoelectric effect will not be observed. At frequency greater than nu naught, when the frequency is more than the threshold frequency, the ejected electron comes out and certain kinetic energy is also provided to that. That means a part of energy, a part of frequency is utilized in ejection of electron and the other part is utilized in providing the kinetic energy to the ejected electron, due to which it can easily move. So you have to note down all the characteristics also of the photoelectric effect. Next important phenomena that is observed on the basis of your Planck's behavior, that is quantum theory, is the black body radiation. Now what is a black body radiation? See, a black body is you can say any substance which is black in color, perfectly black in color, and it is actually a perfect emitter or absorber of all types of radiations, and the radiation which come out from the black body is called a black body radiation. Now this was also explained on the basis of your Planck's nature, that is the particle nature, that the perfect black body is absorbing or emitting radiation, but it is absorbing a quantized radiation only. Now after this came the Bohr's model. I have already explained you about the Bohr's model, and today we have learned about the developments that led to the formation of the Bohr's model. Now children, do revise all this. Do note it down in your fair notebook. So about the Bohr's model we have already learned, and in the next presentation we will be learning about the next atomic model. Before that we will study about the developments leading to the quantum mechanical model of atom. So after Bohr's model we have to study about the quantum mechanical model of atom, but before that we will study about the developments leading to the quantum mechanical model of atom. Thank you children. Sai Ram.